And University of Alaska Fairbanks went to Nome, used a quadcopter to create this an orthomosaic map of the area that covered, that was made up of over 1,000 pictures, which were electronically sent to labs in the US and in Canada, and then returned overnight so the Coast Guard could use them. By the way, if anybody wants to jump in on any of this and tell more of the story, please do. So the pictures, or this picture map that UAF created, was used to shorten the distance from the Renda delivering the fuel oil to the header up on the dock. Originally they thought it was going to be about a mile, but because of that orthomosaic map, they were able to bring the Renda into within a quarter of a mile of the dock. After they got it there, then the problem was, well, where are we going to lay the hose in order to get it over that quarter of a mile? And this again was accomplished, or made a lot simpler by the University of Alaska Fairbanks. They took this oblique and put it up on a whiteboard. And then the Coast Guard Ice Commander just picked up a marker. And he said, well, we're going to put it right here, and we'll go around that, and over here. And that's how they made the map of where the hose was going to go, instead of sending men out on the ice to probe for the weak places in the ice, and they didn't have to risk the people in order to do that. The work up at Nome was accomplished in temperatures between -20 and -30. The flight times were approximately 15 minutes because of the cold temperatures and the effect on the batteries. The ground control station and the pilot who was flying were inside the vehicle. The batteries were kept warm on the defroster of the car. And the PIC and the visual observer were outside of the vehicle. The PIC was talking through a slit in the window about like this. It developed a three-man team that worked pretty well, with the PIC not being the manipulator of the control, but being the center of communication from the visual observer to the flying pilot. And they operated in Class E to the surface. And it was the first time, or one of the very first times, that the FAA issued what they called a humanitarian code. It took less than 3 days to get that done, which was record time back then. Probably accomplished in 3 hours today. This is another ice study that was done up at Barrow, and it was done to reduce the risk of people that were operating out on the ice. You want to say anything more about that, Kathy? Or?
Is A all up yet? No, then I'll jump in. So, for those of you who don't happen to be Alaskans, can you hear me without the mic? Yes. Okay, we're just going professor mode. 200-person lecture hall, not a big deal. So, with this particular case, we have whaling that occurs, subsistence whaling. It's a traditional activity. And in order to get your boats to the ocean, in order to hunt the whales, what do you have to do? Well, there are all these pressure ridges in the ice that are formed up against the land. And the community goes out and chops trails through the pressure ridges in order to flatten it out to be able to haul their boats to the open water. So what we did is we went out with a hexacopter, a ptarmigan created by Northern Embedded Solutions, and flew orthomosaic, back and forth, mowed the lawn over a fairly small area, and went through structure from motion and developed a three-dimensional look at the ice. We developed several of these. This is one that we color-coded by height. We're all scientists. What do we see? We see the height. That makes it easy for us to determine. We also had some that were in natural color, the real color of the photographs. And what we found is the community often did better with the actual ice map, with the, you know, all the whites, just because that's what they're used to seeing. They could read the ice. And for us as scientists, we like the color. It made it much easier for us to find where it was high and low. But this is something where we can help the community determine what's the fastest way to the open water with the minimal chopping through all of this frozen ice pressure ridges. And this is something we're hoping to repeat in spring, but it is a case where being able to do that structure from motion can help a community save themselves a whole lot of effort. And so what we pioneered with the Renda has other uses, and of course structure from motion now is becoming a very, very common, people have it on their own desktop type way of processing data.
Okay, thank you. And, you know, as we go through these slides, if anybody knows more about the story, then please, you know, join in. And this is about this work that you've done. Funny River Fire. Is Marty in the room?
Marty is in the other room. It's my cat field here.
I guess not. When the Funny River Fire was going on, I was driving to Kansas, and Marty and I were talking on the phone for hundreds of miles across the of highway down on River 48. They were able to move the launch and recovery vehicles for the Scan Eagle inside the TSA, TFR, thank you. Too many acronyms. And they were able to fly at night when there weren't any other aircraft flying. They discovered a lot of hot spots that would not have been discovered otherwise. And we have, there's work that's been done up here in Alaska for, you know, flooding due to the breakup of the rivers. And were you working with the National Guard on that project?
No, this one was with NOAA, and there will be a briefing on it later today.
Okay. This was an interesting event. There was a team of people from DC that were here taking a look at the test range, I guess 1 year after the test range had been set up. And while they were here, the university got a call from the state police, the state troopers, said, we have a hazmat accident about 2 miles away from your headquarters at that time. And could you come out and do a survey with your unmanned aircraft? And they were already doing, the state police were already doing their traditional survey with sticks and measuring tapes and that sort of thing. And I think their survey probably took 3 or 4 hours. The university loaded everything they needed into a van, went down, flew this mission in about 20 minutes, and created this map overnight so the police could use it. If you notice the cars going by there aren't all packed up, most of them didn't even realize that there was an unmanned aircraft flying in the area. And they weren't, rubbernecking, looking out the window at it. It was flying above what they could see through their normal vision in the vehicles. It really worked very well. And I think this is one of the first ones that was actually done in a traffic situation in the nation.
One one lesson learned from this is you have to train the first responders not to look at the aircraft. Because it's cool, they're not used to it, they all want to look up and see what's going on, at which point the drivers will look up. So you need to work with your teams to say, don't watch the aircraft. Whatever you do, don't watch the aircraft.
Okay. Now, we do a lot of work with the military up here in Alaska. You know, they have Shadows, Ravens, Gray Eagles. They have a lot of unmanned aircraft up here. But during one of the early events, University of Alaska Fairbanks went into Fort Greely. This was during maneuvers. You know, it's the Red Army against the Green Army or something. And this is kind of an unusual thing happened. The university was able to fly the Scan Eagle and real time display the information on the notepads that the Army was carrying. And this one team said, well, I know we're supposed to be captured, but we don't have to do that because we know where the enemy is, we can turn this around. And headquarters says, no, this time you better stick with the scenario, but we'll think about that for the next time. Alaska has coastal launch sites. The 112th Congress in section 332D said that there will be coastal launch sites into the Arctic so people can operate from the shore out over the water with ingress and egress. Those flights can go up to at least 2,000 feet. Notice the at least, not, you know, no higher than 2,000 feet. 24/7 for commercial and research purposes. And so we have coastal launch sites now that extend from the Canadian border. I think there are 9 of them that come around to where the elections start, and then the entire pollution chain from here all the way out to Attu, on both sides of all the islands, or all sides of all the islands, are available for commercial or research purposes. These are underused. Somebody needs to get out there and take advantage of these sites.
Hey Jay?
Yes?
Could you explain a little bit more about the egress? Because there's a certain limitation, I guess, from the sites out to what's defined as
Are you talking about the corridors, Larry?
Yeah, if you wouldn't mind.
Why don't you tell the people about that?
It was kind of a funny thing, and I don't mind sharing this, because when they did pass the law, and they talked about the Arctic, I started getting calls from people I didn't even know existed.
And the reason why is because they said, so tell us where the Arctic is. Well, in the ATC world, there is an Arctic Flight Information Region, but it really wasn't what was intended to be met for the law. The law was to allow them to have egress to it, because the Arctic Flight Information Region actually starts several hundred miles off the coast of Alaska to the north. So when we were going through this, they just various things trying to come up with lat longs and coordinates to define the areas. It was virtually almost impossible because of our land mass and how much area it encompasses. So the first iteration I think I saw when they said, here's our suggested egress ones, there was like 140. Remember that? And no, it was just the establishment of egress and areas and places to launch. So I kind of lost track of it as time went along, and I realized that the numbers had whittled down to more manageable. But I never did find out what the widths of those corridors were supposed to be as defined by the rules.
Well, I guess we'll find out when somebody wants to use one. This is one of the corridors that Laurie was talking about. This one was Misopex, and it was a sea ice study. You can see the corridor right here. I think the top of that was 400 feet.
It was pretty low. Yeah.
It was pretty low.
Out to
And it
12
was-
miles. Out to 12 miles, yes.
Hmm?
Out to 12 miles away. That's basically.
Yeah, it went out for 12 miles. And then they were in international airspace and were able to fly pretty freely at that point. Sorry. Mark, do you want to tell them about this?
Jim put up some maps in my talk after lunch, so we'll talk about this in detail, but. I'm Mark Ivy from Sandia Labs, and I'm going to give you maps in more detail about this in my talk after lunch, but we've got a restricted area. We, that is Department of Energy, and Sandia manages that restricted area for DOE. So we've got a small restricted area, 4 miles in diameter, right over the top of Electoc Point. And then starting in international airspace offshore, we've got a warning area that actually goes 700 miles up to the north, about 40 nautical miles across, segmented so aviators can get across. We just turn on the areas we need when we have activities. But Jay was talking about Misopex. That was a big scientific campaign funded by NASA. I don't remember the exact acronym, but it's Marginal Ice Zone Observations. So the idea was they were going to fly unmanned aircraft north over the edge of the ice and bring them back. So that was the first instance when we figured out how to get an unmanned aircraft from Electoc Point to international.
As I said, this is your story. So as we go through these things, if there's something